And being a parabola and being a power function, it is going to have a domain of all real numbers. And the range, since it is only increasing to both sides and the lowest value of y is this 0 right there, the range is going to be y is greater than or equal to 0. A polynomial in one variable is an expression in the form of a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot dot dot, etc., 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 where a sub n does not equal 0, a sub n minus 1, a1, and a0 are real numbers, and n is a non-negative integer. I know that sounds really, really scary, but what that simply means is it is a polynomial function that involves whole number exponents. It can have fractional coefficients, but it goes in descending order of exponents. So that's what that m minus 1 and all that means. So an example of a polynomial function is actually something that you've already done so far this year, which is just a quadratic function, maybe just simply f of x equals 2x squared plus 3x plus 4. Because it is in descending order of exponents, it goes x squared, then x, and then the last term doesn't have a variable in it. It's the constant. Again, these terms should be written in order from greatest to least degree. When it does that, it is in standard form. The degree of the polynomial is n, and the leading coefficient is a of n. So the degree of the polynomial is going to be the highest degree, the highest exponent. That is often usually the first exponent you see. However, that is only when it is in descending order of exponents. So the highest exponent will be the degree of the polynomial. Standard form means written in descending order of exponents. So here's some examples of graphs, what graphs look like with certain degrees. A degree of 0 is referred to as a constant function. If it has a degree of 0, it means it has no variable. It might be just simply in the form of f of x equals 2. With no x, that means the y value is always equal to 2, and when the y value is the same, it gives you a horizontal line. Notice a horizontal line does not increase or decrease to either side. We already know what a linear function looks like. Linear functions means that they're going to be in the form of our usual y equals mx plus b. Since there is no exponent to be seen, there is a degree of 1 because there is a 1 behind the x, because if you don't see it in a exponent behind a variable, their assumption is it's always going to be 1. And we know what straight lines look like already. And we've already talked about quadratic equations. Quadratic equations are in the form of y equals ax squared plus bx plus c. You can see our ABC that we identify so many times in Module 3. And we know quadratic equations make a parabola. Maybe it's increasing on both sides, or like this one, which is decreasing on both sides. But notice that it has a degree of 2 because the highest exponent in a quadratic equation is 2. And then we get down to some new functions. A degree of 3 is referred to as a cubic function. Cubic. This is something you do need to know. If you see a third degree equation, which means it has a highest exponent of 3, it is referred to as a cubic function. Cubic functions, being an odd degree, will increase to one side, but also decrease to the other side. Two more functions, and I don't particularly think you need to know the names of these, but it's listed anyway. A fourth degree function is referred to as quartic, Q-U-A-R-T-I-C. A degree of 4 means it's going to either increase on both sides or decrease on both sides. This one increases on both sides, but even functions will do the same on both sides as their end behaviors. And then a degree of 5 is referred to as a quintic function. And notice that since it is an odd degree, it is increasing on one of the sides, but decreasing on the other side. So let's look at example 3. It says, state the degree and the leading coefficient of each polynomial in one variable. If it is not a polynomial in one variable, explain why. So the rules for a polynomial in one variable is that it should be all whole numbers for the exponents. There shouldn't be any fractions which has the variable in the denominator. You shouldn't see any square roots. It just should be in descending order of exponents, and it should be in one variable. So you look at part A. Part A, the degree is going to be the highest exponent. The highest exponent is a 4, so the degree is 4. And the leading coefficient is going to be the number that it leads off with, assuming it's in descending order of exponents, and it's that 2. So the leading coefficient is a positive 2. Part B is 7x to the third power minus 2. This has a degree of 3. That is the only exponent you see, a degree of 3. And the leading coefficient, the coefficient with that highest exponent is that 7. So the leading coefficient is 7. Part C is 4x squared minus 2xy plus 8y squared. You can see that this is not a polynomial in one variable simply because there are two variables. The two variables are x and y. You can only have just one variable to be a polynomial in one variable. Part D, that is a very long problem, but it is a polynomial with a degree of 5. The highest degree that you see, the highest exponent you see there is a 5. And the leading coefficient is the number with x to the 5th, the coefficient of x to the 5th. I don't see 1, so the assumption is that there is a 1 there. So we would say the leading coefficient is 1. Be cautious when you answer these questions that everything is in descending order of exponents. Let's say, for example, it gives us a polynomial like x to the second plus 2x to the third minus 3x to the fourth plus 5. The degree of this function, again, the degree is the highest exponent, is 4. And what's the lead coefficient? The lead coefficient is going to be the coefficient that is with the degree of 4, and that's actually negative 3. Because this is not written in descending order of exponents. It was not written in standard form. Standard form in descending order of exponents would actually be negative 3x to the fourth plus 2x to the third plus x squared plus 5. And then when it's in descending order of exponents, you can see that the first coefficient that we see is that negative 3. Polynomial functions can be used in a variety of different real-life situations. We're going to evaluate this function and also look at its graph. So it says, to help predict heart attacks, doctors can inject a concentration of dye in a vein near the heart to measure the cardiac output in patients. In a normal heart, the change in the concentration of dye can be modeled by the function f of x equals negative 0.006x to the fourth plus 0.140x to the third minus 0.053x squared plus 1.79x, where x is the time in seconds. We are going to find the concentration of the dye after 5 seconds. Well, since x represents the number of times in seconds, that just simply means we're going to replace all the x's with 5, and we are going to find the answer. So our answer is going to be found by taking negative 0.006 times 5 to the fourth plus 0.140 times 5 to the third minus 0.053 times 5 squared plus 1.79 times 5. Depending on the type of calculator you have, maybe you can just plug that into your calculator, but I'm going to follow order of operations. And order of operations says we should be doing our grouping symbols first, which we don't have grouping symbols, but we do have exponents, and that is next. So when we take 5 to the 4th power, that is 625, plus 0.140 times 5 to the 3rd power is 125, minus 0.053 times and 5 squared is 25, plus 1.79 times 5. And then we do all of those multiplications. So the first thing is going to be 625 times negative 0.06, and that's going to be negative 3.75. And then we will add to that 125 times 0.140, and that's going to be 17.5. And then we will take 0.53 times the 25, and that is going to be negative 13.25. And then finally 1.79 times 5, and that is going to give us a positive 8.95. And then finally we add and subtract all of those numbers, so negative 3.75 plus 17.5 minus 13.25 plus 8.95, and that is going to give us 9.45. Then we should make sure we label it. Now, it really doesn't give us much of a label. It says it's a concentration of dye, but it doesn't give us a units to label it with. So we will just go ahead and put 9.45 as our answer, but always make sure that you look at the problem itself and make sure you have a proper label. Finally, we will review the zeros of a polynomial function. Remember, the zeros is another way of describing the answer to a function when that function is set equal to 0. On a graph, the answers can be found by looking at the x-axis. So example 5 says use the graph to state the number of real zeros of the function. So we can see that on the top graph, we have 3 places where it crosses the x-axis. There are 3 x-intercepts. There's one right there, one near the middle, and one towards the end. So the zeros of the function, which would be the x values, the zeros of the function would be negative 2. It looks like it's halfway between 0 and positive 2, so that would be a 1, and then positive 4. And then it also says we should state the number of real zeros of the function. So the number of places that it crosses the x-axis is 3. So the x equals negative 2, 1, and 4 are the actual values of those real zeros. But since it crosses the x-axis in 3 places, it has 3 real zeros. And then the bottom one, we can state the real zeros. There is a real zero right there at negative 5. There's one next to it halfway between negative 4 and negative 2, and that's probably about negative 3. Halfway between 2 and 4 would be positive 3, and halfway between 4 and 6 would be positive 5. And notice that there are 4 places so that it crosses the x-axis, so there are 4 real zeros.